I vaguely recall a commercial a couple of decades ago in which an actor says, "I'm not a doctor, but I play one on television." Given today's subject, an updated analog might go something like this. I'm not a climate scientist, and hardly any of my friends are, but almost all of us have been playing one, not just on television, but everywhere, even in the movies. Never mind that we earned a collective C- in high school physics on the outside chance we signed up for more than 10th grade biology to begin with. Now, this is definitely not to say, I'm quick to acknowledge, that when it comes to critical matters of public policy, such as climate change, advanced degrees are a prerequisite to speaking out. Simple citizenship, simple personhood, ought to afford people every place and everywhere the right to write, agitate, and otherwise express their mind. No credentialed expertise required. But while everyone is entitled to their own opinion, not everyone, as Daniel Patrick Moynihan famously said, is entitled to their own facts. Or more to the central and contentious point I really want to make, it's neither intellectually honest nor ultimately helpful to dismiss inconvenient evidence that runs contrary to reigning orthodoxies by asserting that scientific debates are over when they are not. Likewise, it's neither intellectually honest nor ultimately helpful to question the motives of those whose views fall outside the same kind of politically correct constraints that cripple debate and retard progress in various other aspects of American life. Do I personally believe that climate change / global warming is a potential problem? Of course I do. Do I believe it poses as much of a problem as some acutely worried people do? No, I don't, for a variety of reasons. And would it have been a step forward, again getting to the heart of the matter, not to have received a phone call last week from a journalist, a very good and talented person, though he or she may be, wondering if forums like this one aren't a sign that American experiment is lowering itself by joining up with knuckle-draggers who are determined to deny the reality of and imminent disasters posed by global warming come hell or high water. Yes, it would have been progressive not to have gotten such a stereotyping call, though under the circumstances, I guess the accusation is that the center is blasé about hell and high water. I'm far from a specialist in the field, so it would be intellectually dishonest and irresponsible of me to be definitive in ways others find it fine to be. The fact, moreover, that my own high school underachievements were world-class perhaps reinforces my modesty. But one of the most important contributions American experiment has made over the last 17 years, and that we will continue to make, is to question and test orthodoxies of many sorts, a whole corral of them. This is especially the case when stakes are enormous and passions are stampeding. So hence, once again, it's my pleasure to welcome you to today's program led by Professor John Christie, a real live and distinguished climate scientist who has been known to say, whoa. Let's take a closer look at what we empirically know and where, literally as a planet, we are heading. Dr. John Christie is Professor of Atmospheric Science and Director of the Earth System Science Center at the University of Alabama in Huntsville, where he began studying global climate issues 20 years ago. He also serves as Alabama state climatologist. In 1989, along with Dr. Roy Spencer, Professor Christie developed a global temperature data set from microwave data observed from satellites beginning a decade earlier. For this achievement, he and Dr. Spencer were awarded the National Atmospheric and Space Administration's Medal for Exceptional Scientific Achievement, as well as a special award from the American Meteorological Society. Subsequently inducted as a fellow of the Society, Dr. Christie has contributed to several reports of the United Nations Intergovernmental Panel on Climate Change, including as a lead author. Professor Christie did his undergraduate work in math at Fresno State University and received his doctorate in atmospheric sciences from the University of Illinois. He and his wife Babs, whom he met when they were both missionaries in Kenya, have 2 grown children. Dr. Christie will speak for 30 to 35 minutes, as usual, after which I'll roam the room for questions. As usual, please be brief. Please introduce yourself if if I don't. And remember, don't be offended because I never let go of the mic. Please welcome a very good and brave scientist, John Christie.
I want to thank you very much for having me here. I'm just a working stiff scientist, but I felt like I was treated like a king by Mitch and Britt, and so I appreciate all the attention they've given to me. And it's just wonderful to see all of you here on this topic that has been something I've been studying since I was 12 years old. And so climate to me is a real important part of who I am and how I've developed through the years. And I've seen it become, rather than a science, more of a political and religious issue as time has gone on. So let's look here. Michael Crichton is famous for saying consensus is not science. You hear a lot about consensus says this or that. If you think about it, if you have to argue about an issue and vote on it or something like that, that's not science. That's a political kind of activity. However, we do know what science is. And 150 years ago, Lord Kelvin told us that all science is numbers. You can measure it, if you can put it into a number, then you know something about what you're talking about. My favorite author said this: some people will do anything to save the earth except take a science course. And that was P.J. O'Rourke. And he actually had numbers to back it up where he showed that Americans are taking fewer and fewer of the hard science courses. We have fewer and fewer American graduates in the hard sciences today because science is hard. It's just hard, and a lot of people don't like to do it. Well, here are some basic numbers, and I want to focus on numbers because that is what science is about. Carbon dioxide has increased 35% in the past 150 years. At the same time, the global surface temperature has risen about 0.7 of a degree in the past 100 years. Now, if all that happened in the climate system were a doubling of CO2, we're about halfway there now, a doubling of CO2, the temperature would rise about 1 degree C. Now, where the issue comes in about global warming is the associated feedbacks. If carbon dioxide warms up the planet, do other things get kicked off and warm the planet even more, positive feedbacks? Or do other things happen that actually mitigate the carbon dioxide effect and cause the planet not to warm as much? Are these positive or negative feedbacks? It's a very contentious area in our science, and one for which there are no confident numbers. So someone who says they know what the climate is going to be doing is not someone that's really in our science. Now, human beings produce about 7 to 8 gigatons of CO2 per year. It's mainly from energy production. Okay, about half of that stays in the atmosphere. So half of that CO2 that we produce stays in the atmosphere. And in total, there are about 740 gigatons of CO2 in the atmosphere. So that means there is a growth rate of about 0.5% per year. So every year, there's about 0.5% more carbon dioxide in the atmosphere, and that's a greenhouse gas. Now, here's some other basics. Climate is always changing. The global surface temperature is never level and steady. It's going up or it's going down. Sea level is either rising or falling. Glaciers are either retreating or advancing. And if you think about it, which would you rather have, retreating or advancing glaciers? And I think here in Minneapolis, about 25,000 years ago, you would have preferred retreating glaciers than a kilometer thick of ice right on top of you. And here's another important thing that here is where people are not scientists, and many of them are inside the Beltway in Washington. Climate cannot be adjusted in a predictable way. The initiatives that are sought to, quote, control climate have no dependable outcome, and the initiatives proposed to date have such tiny impact that we can't even measure what impact it might have anyway. This is a picture you've seen quite a bit. This is the global surface temperature record of the last 150 years or so. And what you see is a downward fall to about 1910, then a rise. These are thought, or at least we are told that that is due to Mother Nature. Then there was a cooling from about 1930 to 1975 or so. That is thought to be due to Mother Nature, as well as some pollution that causes sunlight to be reflected. Then this warming right here is, we are being told, is due to human effects. The vast majority of that is due to human effects, is what you are told from all these assessments and so on that are going on. I'm going to talk a bit about that global surface temperature network and some of the pieces of it. Now, this is in Fresno County, California. Didn't know that there were glaciers in California, but there are glaciers in the Sierras. You can see that from 1908 to 2003, a lot of the glacier is gone in Darwin Glacier. This is a part of the world, the western United States, in which the glaciers are only 5,000 years old at most. Before 5,000 years ago, there were no glaciers in the western United States, as far as we know. They developed in what was called the neoglacial, the cooling period that started about 5,000 years ago. Well, I wanted to know what was going on with climate there, especially having been a native of the area. And this also tells us something. If you look carefully, you'll see the San Joaquin Valley is this big area right here, and you'll see it's all green. And this is July. It's all green. And on the edge, you see this light brown or tan color. Well, it's green because of irrigation. Normally, that should be a desert. So I did an experiment funded by the National Science Foundation to find out what was going on in the valley here in terms of climate and what was going on right next door in the Sierras in these foothills right here that have not had that massive change going on. What was causing any change that might be observed? This is what we found. It was published last year, that in the valley, the nighttime temperatures are just soaring. There's just no question it is getting very hot. In the valley, the nights are getting worse and worse in terms of high temperature. But right next door in the Sierras, there's actually a slight cooling trend. That tells us fairly well, in my view, what is causing the warming there. It's the change in the land use from a desert, a dry desert, to a moist, irrigated plain with lots of cities. And I have sent many letters to California people who think they can control the climate, saying that if you want to return the climate back to what it was in the 19th century, you need to depopulate the valley and return it to a desert. That's the only way you're going to do it. And all of these issues that are brought about in terms of controlling greenhouse gases from automobile emissions will just do nothing. That this is what you have to do. This is what science shows us. Climate models show us something different. They say if greenhouse gases are causing the change in California, the mountains should show it first and not the valley. We actually see the opposite occurring, where nothing is happening at all in the mountains in terms of temperature change. Everything's happening in the valley. That's another indication that what is happening is not due to greenhouse or carbon dioxide warming. In Alabama, we have a different kind of issue. Our temperatures are falling and have been for the last 115 years. We had all-time record lows this past Easter with the freeze that came through. And we used to have a citrus industry in South Alabama. It's no longer there anymore because it's too cool. But when you have climate models that try to project that, every single one we've been able to find says that for the last 110 years or so, the temperature should have risen. Every single one of them. Whereas the observations are in blue there and show the others. So for someone like me in the science, and these are numbers, no one will argue about those numbers, is that we've got a problem with climate models and the way they try to replicate what's happened in the real world. I'm going to skip this part about upper air temperatures. It gets a little complicated, but I will show you this. This is our satellite data set, and what we have found is that the warming rate of the bulk atmosphere, and that's where the greenhouse effect is most clearly found if it is happening, is 60% of model projections. And that's within the range of natural variations. Now, I happen to believe part of that is due to human effects. I'm not someone who just denies any kind of human effect on the climate system, but it's at a rate that is not catastrophic. And these are global temperatures. I like to talk about this part, cold places, because you hear nothing about but sad and disastrous things happening in cold places. Okay? If we go to the Arctic, North Pole, and we're going to start at the North Pole and go to the South Pole. The sea ice there has been declining. There's no question about that. Since 1979, when satellites started measuring it, we see this drop in ice cover of the Arctic. And the temperature has risen. If you look from 1850 to now, you see that in the last 30 years, the temperature has indeed risen in the Arctic. But what we don't have are satellites from 1920, 1930, and 1940. Where you see this rapid rise in the Arctic temperature to its record values in 1938 and 1939, And one would wonder what the satellites would have seen when it was the same warmth back in that period. So what is happening in the Arctic is certainly real. The ice is going away, but one wonders how many times in the past has that occurred. Let's move a little south to Greenland. Greenland is important because the alarmist news today is that sea level is going to rise 20 feet in the next century. That happens because they think Greenland will melt. Okay, Greenland has to melt to get that sea level to rise 20 feet. What you see here is, yes, in the past 30 years or so, Greenland has been warming. But if you go back to the 20s, 30s, 40s, and 50s, you will see that Greenland was even warmer than it is today for 4 decades. And in fact, Greenland did not melt during that time. Well, let's go back 1,000 years in Greenland. We see today's temperature right here on this bar. And you'll see that 1,000 years ago, the temperature was much warmer than it is today, and Greenland did not melt. In fact, the poor Vikings landed on Greenland and started their business right there at the peak. And as we all know, the Greenland experiment, it was named Greenland because there were green barley fields that they grew. The temperature declined after that, and about right here, 1400, there were no more Vikings because it got too cold. But here's a long period, about 1,000 years warmer than it is today. And yet Greenland did not melt. That's not enough for you. Let's go back 10,000 years, okay? This is 8,000 BC to 2000 AD, and you see here a period of over 4,000 years in which a temperature was much above what it is today in Greenland. Greenland did not melt. In fact, some of those centuries were probably 3 or 4 degrees warmer than it is today. Celsius, I'm talking Celsius here. So the evidence here, and this is what I presented in federal court just a month ago to rebut a witness who was bringing the case that Greenland is going to melt in the next 100 years. I was telling the judge, it was a bench trial, here is evidence Greenland has been much warmer in the past, and yet it did not melt. And these are real numbers here. Let's go to Alaska. We hear a lot about Alaska, and if you look at that, a climatologist just says it goes up and down all the time. You really don't see much of a trend there, especially the last 30 years have been relatively flat. Let's go to Western China. Just look at the last point here. Observations are consistent with increasing snow trend. In other words, those Himalayas in Western China and so on are not losing their snow like some news reports tend to tell you. Let's go to a favorite place of mine. I spent time in Kenya, and this is in Tanzania, right next door, Kilimanjaro. When you look at the first time in 1880 when the snow was surveyed on Kilimanjaro, there was about 20 square kilometers. Today there's about 2. So the snow has been leaving. It has been disappearing from Kilimanjaro. However, when Hemingway wrote Snows of Kilimanjaro in 1936, half was already gone at that time. That's a very clear indication that what is going on in the snow caps there is the fact that there has been a large circulation change that has brought less cloudiness and precipitation to Kilimanjaro. And so the snow has been melting naturally since that time. In fact, this past year, turned out there was a mass gain. The instruments were covered up with snow. They had so much snow in November, December. And so we don't have a good, but there was more snow, so there might be an uptick here soon. And we built a data set of temperature around Arusha and Kilimanjaro. And we find for the past 55 years, no change at all in the temperatures. No change at all. We have multiple data sets that show the same thing. Kilimanjaro is not melting because of a temperature change. It's some other issue with the circulation. Yet it's a poster child, you know, for global warming. Well, let's go to the Andes. We're still going south. Now we're going a bit west here. 55 years worth of snow cover in the Andes Mountains from the snow course from Chile to Argentina. The first half of that record is here, average. The second half is here. There's more snow being recorded and measured in the Andes. Now let's go to one of my favorite places, Antarctica. This is the one you never see. This is the sea ice coverage of the South Pole, the sea ice that's around the Antarctic continent. Remember that one from the North Pole, how it showed the trend going downward? The trend here is upward. There is more sea ice around Antarctica today than there was 30 years ago. Penguins are having trouble getting out to the sea, to the water to feed because they have to go over more and more ice each time. And as I said, this is a picture that is not consistent with the story of gloom and doom because it says sea ice in this side of the planet is growing. If you look at that picture of Antarctica, if you see a warm color like yellow or red, that tells you the snow is accumulating. And most of Antarctica is having snow accumulate. Again, not a story you see much about in the press these days. And the temperature, if you look at the last few decades here of Antarctica, the temperature has fallen there as measured by the several thermometers that are available around there. So in the South Polish area, you don't see these kinds of changes that cause you alarm. Now, what about sea level rise? Well, here's just a paper out last year. You see that sea level has been rising. Remember I said sea level is either falling or rising? You know, it's never just steady. It's always going up or down. And there is ice melting, and also as the seawater warms, it expands. Notice here the end of the Little Ice Age. That's when it was the coldest, perhaps in the last 10,000 years, just in 1850. So we're recovering from a time period that was fairly cold around the planet. And sea level then rises as a result of the water expanding and some of the glaciers melting. So if you look at the three things that cause sea level rise, this one right here is the water expanding from heat. This right here is Greenland melting. Some people think Greenland is melting a little bit. And this one right here is Antarctica, because the models guess that Antarctica is accumulating, so it's sucking water out of the ocean and causing it to decline a bit. And the net for all of that, the IPCC tells us, is about inch and a half per decade. And I think if you are susceptible, if you are vulnerable to an inch per decade sea level rise, you're in trouble already. Because the next hurricane that comes up is going to bring 15 feet of storm surge, and 1 inch per decade is nothing compared to 15 feet in 6 hours. Now, I suppose in Minneapolis you don't worry too much about hurricanes here, but in the Alabama Gulf Coast we do. We do. What about extreme weather? Are tornadoes going up? No, they're not. We can count tornadoes. All science is numbers. And those are the tornado statistics. For the United States, and by the way, 1/3 of all tornadoes in the world occur here, so we have a good sample to look at. Hurricanes, are they going up? No, they're not. In fact, this is 6 different parts of the world. It turns out that in some places you can see a rise in hurricane activity, some places a fall. It turns out, globally, there's about 95 hurricanes a year, every year, year in, year out, about 95 hurricanes. It's not changing. What about drought? This is a study that shows us that if you see blue on that map, that means droughts are fewer and shorter in length. Now, if you can see that, I think you see a lot of blue there. In other words, droughts are not becoming significantly different. In fact, they're becoming less. So, what have I shown so far? The global surface temperature is rising, but it's in a way that's inconsistent with the way these projections of greenhouse gas models show. The overall decline in ice mass is there, but the sea level is rising at about 1 inch per decade. That's not unusual at all in the climate system. And severe weather is not becoming more frequent. But, you know, is alarmism winning? The Supreme Court says carbon dioxide is a pollutant. As a scientist, I just could not understand how that could occur. But the Supreme Court has declared in a vote 5-4 that carbon dioxide is a pollutant, even though the fact that plant life depends on carbon dioxide and would love to have more of it. It's plant food is all it is. Then there's Al Gore, you know, with Academy Awards and school presentations everywhere. I was telling some of the people that I get emails from all over the country saying my school system requires me to show an inconvenient truth. Do you have some material at least I can try to bring about? And one school system, in fact, denied any alternate view of that. East and West Coast states are legislating emissions controls. Presidential campaigns have global warming about every 4th point. There are one-sided congressional hearings right now in Congress going on, and then there's this Intergovernmental Panel on Climate Change, really a series of bureaucrats advocating for alarmism. So, you know, I think you would say, yes, it looks like alarmism is winning in terms of swaying people's opinion. Well, I want to say I don't see a disaster developing, but suppose you do. And I think there are probably some here in this group that feel this climate change and global warming, that they've been convinced it really is a problem, and so something should be done about it. So let's go to see what we can do. I always think about the American public as the safety net, because we have a democratically accountable system here, and if that congressman, that senator doesn't respond to its constituency, then he's in trouble. In fact, I was at a congressional hearing just 2 months ago when one of the congressmen was talking about this, and I just said, well, I would hate to run on the platform in my next re-election on the platform that I raised your price for gasoline, I raised every utility bill that you write a check for. You know, that's pretty hard to get elected on. But that's what would happen for many of these kinds of bills that are being considered. Well, anyway, if the American public knows this, that without energy, life is brutal and short. Okay? They understand that, and I think they do. Global warming proposals will make you pay more for your gasoline and electricity in every product you buy. And thirdly, global warming proposals will do nothing to alter the climate. So if those three things, I think, are known in terms of the public, I think we'll deal with this a little bit more intelligently. Consider this. In 1900, the energy technology of the day supported 56 billion human life years. Okay, that's 1.6 billion people times 35 years life expectancy, 56. In 2005, 429 billion human life years. To me, that's a spectacular achievement, the greatest achievement of human society ever, that we have grown eightfold in the experience of human life. I'm a grandparent today. That would not have been the case 105 years ago or so. And you know, I look out here and I suspect many of you are grandparents as well. In all likelihood, we would not be here, but for the energy technology that's available, but for that extra carbon dioxide that is in the atmosphere, that is there because it has helped preserve, secure, and extend human life. Okay. I was a teacher in Africa. I taught physics and chemistry. Most people go to Africa to see the giraffes. This is a reticulated giraffe up in Samburu. I was there for people. I taught the students. I lived in a small rural town and lived right amongst them. So to me, Kenya is the people that live there. Here is their energy system, and I saw this every day. That's the source of energy, wood, a forest. The energy transmission system is the backs of women. They would get up at crack of dawn, go on an average 3 miles to the edge of the forest, chop down the wood, carry an average of 50 pounds of wood back to their homes, and then this was the energy use. They would burn the energy, the wood, in their home, and you can see that smoke column right there. That's what I really want you to see, because the UN estimates between 1.8 million and 5.2 million women and children die each year simply because that is their source of energy. So if you're concerned about living people, you would be concerned about that energy system. That's a country that needs a coal-fired power plant. If you put in a coal-fired power plant, you save the forest. I mean, this habitat is being destroyed because that's their only source of energy. And if you want to save the people, then that would be one thing to do, and save the environment as well. It's far more healthy to have electricity than to be breathing this every day. And having lived there and walked into homes like this, it just takes your breath away because of the particulates and the serious problems that result. So here's the dilemma here. Energy growth is going to occur. The demand for energy will rise, period. So how are you going to supply affordable energy? I mean, benefits are just ubiquitous and innumerable. People want energy. It brings health, security, longevity, and so on. And at the same time, how can you reduce CO2 emissions substantially so that there might be a detectable impact? And I'm talking about massive reductions here so that you can, quote, manage the climate. Now, like I said earlier, you can't manage the climate in a predictable way, but let's just assume we can, okay? But I have this thing down here in orange. It will not be possible to claim a policy of greenhouse gas reductions will, for example, change the number of sub-freezing days in Minnesota to the number experienced in the 19th century. In other words, if you want to return the climate to the 19th century, we have no way to predict how you can get there from any of the bills you might propose. Oh, well, anyway, so what can you do? You can have a socialist solution. So that's where you have a centrally planned, top-down regulatory process, okay? And lots of people like this. Like the Kyoto Protocol is a good example. But as it turned out, the verification was very difficult or even unknowable. The violators were volunteers, so how do you beat up on someone that was a volunteer? The non-violators simply learned how to game the system. And this was something that people in America could have seen coming a mile away. But in Europe, they don't think about this. That you set up a regulatory system, what's the first thing you're going to do is find a way around it. And that's all that happened in Europe. Their emissions are going up faster than the United States emissions right now. Did you hear that? In the last 7 years, the European emissions of CO2 have gone up faster than the United States. And we don't have any of that regulatory control. And there was just, this last one here, there was just very little realistic appreciation of the world's appetite for energy. It makes life better. And when people can have a better life, they're going to go after it. Okay. Well, some in the United States want to change the climate back to something. This is the IPCC best estimate of the next 100 years of temperature change. And you see it goes up to 2.8 degrees Celsius in 2100. So the governor of California, the legislators, decreed that by 2016, all automobile emissions of CO2 will be dropped by 27%. Never mind the fact there is not one single automobile manufactured in this country that meets that requirement today. They just set it as a decree. And so 11 northeastern states bought into this, and they signed up to AB 1493, the bill in California, and made it law in their states. 2016, all tailpipe emissions will be a certain, I think it's 205 grams per mile. So, at the federal court case in Vermont, where I appeared as a witness, I had done the calculations. This is what would happen to that temperature record if every state in the union bought into this thing and achieved the goal of reducing automobile emissions. Okay, watch carefully. This is the effect. The red line is still there. Okay, it's still there. It amounts to a grand total of 1/100th of a degree by 2100, which we can't even measure. I mean, I build climate data sets from satellites and all kinds of things, surface observations. We can't measure that. You would not know it. And yet, that is the gain that would be achieved by a massive overhaul of the automobile industry. Now, let me just do that again. I like to do that. Okay, this is the current guess for coming temperatures. I think it's way too high, but let's just suppose it's okay. This is the effect. Okay? Well, what about a free market solution? Innovation will deliver new sources of energy. Well, that requires investment and invention, and since there's risk, people like government subsidies to go along with that. And so we have ideas of nuclear fusion, like the sun. Let's build a little sun here. That's always been, ever since I was a kid reading about physics, it's always been the next source of power, and for 50 years it's been the next source of power. How about carbon sequestration? In other words, you suck the carbon out of the air and just bury it somewhere. Well, that has not been shown to be financially feasible. And it turns out that there's huge liability. Suppose you did suck a lot of carbon out of the air and stick it in a cavern somewhere, and then you had a leak. Because that's what happens in the real world of geology and so on like that. And so the liability is pretty significant there. Can we burn coal that doesn't produce CO2? It's similar to the carbon sequestration. Perhaps some clever person will figure out how to keep the carbon dioxide from being emitted in a coal-fired power plant, but to do that requires lots of energy. So you just burn more coal to do that. Maybe there's some hope there. Fuel cells, the hydrogen source of electricity. Listen, I bought stock in a company that builds those several years ago. If that stock doubles today, I will have only lost half my money, okay? Now think about that. But here's the key on that. It was my money. the government didn't tell me to do that or something like that. And it's a risk I took. And who knows, somebody might crack part of that fuel cell thing and come up with a clever design that will work and that won't, have a hydrogen tank that blows up and destroys a city block in a car. But hopefully there will be new sources of energy coming. I'll say something about that. Well, what else can you do? You can change behavior. You can start an environmental religion and just demand that your people have a primitive lifestyle. And I think we see a little bit of that going on right now. But as we all know, that's not going to catch on. People like energy. I can't emphasize this enough. It makes our lives so much better, so much healthier, so much longer. Energy demand is just going to continue to rise, especially in places that I've been and probably many of you overseas. Energy demand is going to rise there. You can tax carbon significantly. Anytime you raise the price of something, you use less of it. So if taxes are placed on gasoline, coal, or whatever, that would impose a more primitive lifestyle. Now, of the three I show here, that's the most likely to have an effect. If you wanted to reduce the carbon dioxide emissions, make it cost more. That's the direct way to do it. Again, though, it's going to be difficult for a democratically accountable body to come up with a way to make you pay more money for your energy. Or you can ration energy. Just say that the United States is only going to use X amount of carbon for its energy and have a bureaucracy, a huge bureaucracy that figures out what sector gets how much, and you can imagine why that's going to go crazy. And that's why Kyoto, by the way, failed in Europe, was you had all these bureaucracies trying to guess, well, this industry is going to use this much carbon, this one's going to use this much carbon, and of course it turned out they gave away far more credits than were even used, so the energy companies ended up making money on the deal. And of course the CO2 emissions just rose anyway. Well, what about alternative fuels, wind, solar, biomass? When you talk about energy, it's a huge amount of stuff. And these sources just don't meet the baseload consistent requirements. They're going to be in single-digit percentages for a long time. Maybe there might be a breakthrough, perhaps in solar or even biomass if cellulosic ethanol comes into play. But they're expensive. They take so much land. There's tremendous transmission difficulties with these sources of energy. Lots of negative environmental impacts. I have a little bit of hope for biomass because if you grow it in a place that has a lot of water, if you take a 10 by 10 foot square, you can grow 1 gallon of ethanol, 10 by 10 foot. It takes 1,000 gallons of water to grow 1 gallon of ethanol, 1,000 gallons. So you want to do that in a place that has lots of water. Like in Alabama, we have 4,000 gallons fall on that square every year. So you can do it in a place like Alabama. But it is crazy to go to Arizona to grow corn to make ethanol, or California or somewhere where you use irrigated water. You are literally burning your water when you make ethanol in a desert like that. Anyway, there could be some hope in the wet places like Brazil, Central Africa, or Southeast U.S. But you could also start a massive program in nuclear fission power plants now. It's doable. There is some resistance, but it has a chance to make a dent in the emissions. In democratically accountable systems, they've been very, very safe, which makes you worry about countries like China that are going down the nuclear road that aren't democratically accountable. What kind of system is going to keep that thing safe? Yesterday, you might have read it in USA Today this morning. Yesterday, Browns Ferry Plant number 1 started putting electricity on the grid. It's 25 miles from where I live on the Tennessee River. It's the first nuclear power plant startup in the 21st century in the United States. So it can be done. We do know how to do nuclear. Well, okay, here's some numbers. All science is numbers. The human population currently uses energy at a rate of 14 terawatts to its considerable benefit. That's just a bazillion if you don't know anything technical, okay? This is a huge amount of energy. And when you hear about these, the megawatts here and the megawatts there from solar or wind or something like that, there's terawatts, there's gigawatts, and then there's megawatts. So now you're a millionth kind of thing. That's why they're never going to really play a big role. 14 terawatts. Most of that comes from burning carbon, therefore releases CO2. So to replace 10% of this, 1.4 terawatts requires 1,000 nuclear power plants, 1.4 gigawatt each. The Browns Ferry plant that started up yesterday is a 1.2 gigawatt plant. Okay, what will that do? Okay, remember this. And now we're going to build 1,000 nuclear power plants now so that they will all be operating by 2020. Okay? That is the effect. By 2050, 7/100ths of a degree, which we can't measure at this point, and about 15/100ths of a degree 100 years from now. You can see an effect, finally. At least you can see a dent. And if you understand anything here, maybe it's the scale of what energy use is. Because so many people use it, so many people want it, it is a huge thing, and to make a dent in it takes a huge enterprise. 1,000 nuclear power plants will do that. Or is there a more rational approach? I'm giving a talk in the Senate on the Hill here on Friday, and that's the title of it, A More Rational Approach. In 50 years, will we learn that the most cost-effective path was to adapt to the changes we actually observed and measured, rather than try to outguess Mother Nature's course? Go out there, see what's happening, and adapt to what's happening. In Alabama, I suppose it would mean buy more coats because our temperature is going down. Or move north to Minneapolis. In 50 years, will we be surprised not by climate change, but by the inventive minds of our scientists and engineers as they discover profitable and affordable ways to generate energy without carbon emissions? The line forms behind the United States when it comes to innovation. This is the country that's going to bring to the world the clever things that are going to get us to the next type of energy. And you get there by research and development. But you don't get there by decree. You know, you will make a car that uses 27% less fuel that people will buy. The only car that meets that category right now is one of those things called a smart car. And it's about this wide, this long. It's about this long. 2 people squeeze into it. So if you've got a family of 5 or 6, that means you have to buy 3 of them, you know, just to get down the road. And heaven help you if you have to buy groceries or something. I think, you know, I see the United States doing what it's always done. It's just going to find these very interesting, powerful ways to create energy because we are clever, we have this drive into us to do that, and a lot of us just want to get rich because the guy that, you know, makes that energy source or finds it or discovers it's going to get rich. And that's always a motivative principle I've found. In the 20th century, transportation was dehorsified, okay? The United States was at the lead on that one. In the 21st century, energy, I think, will be decarbonized. And again, this country is going to be the source of that work. And therefore, this talk about global warming will be over by then. 2 cavemen are talking. Something's just not right. Our air is clean, our water is pure, we all get plenty of exercise, everything we eat is organic and free range, and yet nobody lives past 30. I'm done. Thank you.
Not only was that terrific, this is why American Experiment exists, so thank you all. That was just terrific.
Thank you.
We have 15 minutes, and I see it firsthand. I'll be going there. And if folks can keep the questions brief, and I truly do welcome questions from folks who might be a bit skeptical of what Professor Christie said. Tight squeezes today.
Professor Christie, you said all science is numbers. Clarkson Lindley, the latest hoo-ha is that the Southern Ocean is getting windier and therefore less able to absorb carbon dioxide. I saw the movie Master and Commander. I read a lot of sea stories. The Southern Ocean has been windy since people have been going down there, and they have 11 data points on the ocean and 28 on land. Is that enough to find out that the Southern Ocean really is getting windier, and therefore, like shaking a Coke can, it can't absorb the carbon dioxide.
Thank you.
Well, that is a good point that drives to the heart of a lot of climate researchers. How good are the data? How good are those data? And I think you mentioned something here that we have very little data in the Southern Hemisphere to make some kind of statement. Well, over this long period of time, we know precisely the change in temperature or wind speed. So much of that area has no measurements at all that I would be a bit skeptical about that kind of notion.
Good question.
Nope. This is Craig Johnson. I have a question on the sources of CO2 emissions to the atmosphere. 1 degree temperature rise in the Earth's temperature. How much CO2 would be released by the oceans?
Well,
Thank you.
that doesn't require CO2 release from the oceans. That's extra CO2 that humans will put in the atmosphere. About a third of that comes from transportation, about a third of that from power generation. The other third comes from industry and deforestation. So those would be the sources of CO2 into the atmosphere. Now, maybe what you're asking is, there's a huge exchange of carbon dioxide between the atmosphere and ocean all the time that's many times the magnitude of what that is. And so it's a little net exchange. What's going up versus what's coming down. That net difference is what I'm talking about here.
Question.
Solar energy, Lee Rodemaker. Solar energy, any hope for if every house that had sunlight would provide themselves with some solar energy? Would that make a bigger dent or make any kind of a dent in the supply?
The problem with it could make a dent in the daytime, of course. In Alabama, we have something called clouds, and so solar energy just doesn't work. We've done all the studies on that in Alabama. The problem there is you have to have something called spinning reserve. You have to have the ability to produce 100% of the power all the time. And therefore, these systems, Germany is a good example with their wind power, they cannot use more than 15% of their total power generation on these alternatives like wind and solar because it disrupts the system so much that when the wind goes down, they can't generate back to 100% to meet the need. 2 years ago, over Christmas weekend, they almost had a complete power failure on the entire German grid because the North Sea became becalmed and they were just barely able to get up to 100% power generation. So that's why they never use more than 15% power from any of their alternative sources anymore.
Walking over to John McLennan. John will be right there, promise. All right.
David Bergerson, I'm curious what your reaction to a thought that I've had, which is, assuming that the major resource of the planet is the gene pool, what about the possibility of bioengineering something that would float around in the atmosphere, ingest carbon dioxide, and excrete solid carbon to fall harmlessly to the Earth?
Well, the imagery there is really...
You know, plants sort of do that right now. But at the root of your question is a fellow named Julian Simon who said, chicken hawks and people eat chickens. When chicken hawks eat chickens, there are fewer chickens. When people eat chickens, there are more chickens. Because people know how to create a resource they like. And so you're saying in that bioengineering that the human capital might be able to develop something that would sequester carbon, is what you're exactly talking about, sequester carbon straight from the air. I tell you what, the EPA would have a field day with you because if you put anything in the air right now, they will want to know, is it going to affect your breathing, your respiratory, and the sunlight and everything else. So it'd be a tough hurdle to get over. But ground-based stuff like that, I have no doubt that there are some nanotechnologies or stuff that are coming down the road that could just suck the CO2 right out of the air and turn it back into carbon. You could burn again and have a cycle.
Walking over to John McLennan. I'm waiting for someone to disagree with some passion, precision, or any kind of disagreement.
It would be the first time.
John,
That's right. Thank you, Mitch. John McLennan. John, I agree with your original statement early on that CO2 is not a bad thing. I own 40 acres of citrus in Florida. I have for 50 years. I now get 40% more oranges each year than I used to because of the increase in carbon dioxide. Same amount of sunlight, same irrigation, same amount of fertilizer, only change more carbon dioxide, more food, more trees, greener grass, better life for everybody. Why do we have to presume that this is bad?
Yeah.
Thank you. I knew there was a question at the end of that. Yes. Yes.
Well, as I like to remark, and I think my number is very conservative here. I will always like to lowball it in case someone jumps on me. Is that 16% of the world's food production is due only to the enhanced CO2 in the atmosphere. Now, if you think about it, that's 1 out of every 6th thing of food is there because of the extra CO2 we put in the atmosphere. And I tell you what, if you took away 1/6 of the world's food production right now, you'd have a catastrophe. So it has a grand benefit. The CO2 concentration was much higher in the distant past than it is today. So it's not like the world hasn't seen these values before.
Before I go to Dan Rosen, let me ask you this. Of all the criticisms that you get, people fighting with you, critiquing your papers, what might be the more substantial concerns that you have to spend a bit more time responding to?
I think it's the hypothetical. What if it really is going to be bad? You know, forget about all the data that don't show too much change, but what if it really, that we believe it's going to be so bad, and therefore we should take precaution. And I'd like to go back to answer that question into what energy means to the world and say, okay, who are you going to let die by following this precautionary principle? Just tell me, and then we will start there.
Thank you. Dan Rosen.
After that answer, I wish my question wasn't going to begin with what if. But what if all man-made carbon emissions, I don't mean from respiration, I mean from cars, machines, factories, whatever, if all man-made carbon emissions stopped, what would happen over the next 20 years?
Okay, the models project the temperature would rise about 0.5 degree. In other words, there's enough CO2 left in the atmosphere that's extra that this effect takes a while to equilibrate. It would take about another 0.5 degree. I wouldn't want to be living in that world, by the way. But
Marianne Nelson, Van Houten. As I'm walking over, folks should know we were in graduate school together just about 20 minutes ago.
You talked about the approach of some government leaders to just setting the decree. Would you talk a little bit about the terrific cost of capital to try to achieve what they're going after versus what we could do by investing that same dollar in research and creative ideas so that we could find a rational, prudent approach?
Thank you. These are good questions today, people.
This goes to the heart and soul of some of my congressional remarks. There are congressmen and senators who are level-headed about this issue, and they emphasize, well, let's look at how much it costs. And because they know they're going to have to face their voters with an extra cost if it happens in their pockets. But when I lived in Africa, if there was anything you could do to clean the water, that's the #1 problem. Kills probably 60 million children a year. 60 million children is what I'm talking about. If you could do that, if you could provide a secure source of energy that would then allow the people to have a light bulb, microwave oven, a space heater, something like that, you would improve livelihoods tremendously in a place like that. But fundamentally, there is another problem in those countries, and that is the dysfunctional governance. A lot of those countries are just ruled by thugs, and getting past that is just the hardest part. And I know our president has been pretty adamant about this democratization, or at least a move in that direction for many of the third world countries, and it's so difficult when you go there and you know the culture and how things just hardly ever change. To me, the best thing that we saw happen in Africa happened when we had the girls able to be enrolled in school. When you had women that could be educated and could be brought through the system in that way, that had the biggest impact on the society that we found. And so educating the girls is I think, one thing that would be provide great benefits that eventually go to the environment and so on like that. But some of these cultures are giving women status is just not on their list of things to do right now, unfortunately.
Let me go to Governor Quee for the last question, and John, if you can incorporate any final comments you'd like to make in response to the governor, that would be great.
Well, I'm interested in what you have learned about the greatest source of energy in all the time, that's the sun. And I hear about other planets warming faster than this one is. So when you look at global warming and global climate change, to what extent do you look at it as the sun? Because the boring shows that the big heat change has occurred in the past and before all this stuff of either automobiles or cow flatulation.
Another wonderful imagery.
Yes, the sun is a big source of energy. It is variable. The way it strikes the planet is variable, and that is certainly a part of the climate variation and change. And I think what you're referring to is that two of the moons of Jupiter, Uranus, and then Mars and so on have all shown warming in the past 10 years. And they wonder how the SUVs got up there, to cause global warming. The sun is a factor. How much it is on this Earth, it's still a matter of science. I mean, it is not settled on what the sun does in the planet, but it certainly over the past millennia and geologic time has been the major factor of climate change. I hope that answers many of your questions. I'll be around a few minutes, I think, afterwards, and I just really had a wonderful time here and appreciate all your attention, and thank you very much.